And I'm live. That is cool. And today is 31st of August 2025, Sunday. And today I am doing a little different thing. Here in my OBS, I am using my kbps at 10,000 and I have changed my latency to be low latency. Up till this point, it was normal latency and latency was pretty high. And the lower bound for normal latency is 15 seconds, which is very high. And for low latency, the upper bound is 15 seconds and the lower bound is 7 seconds. That is much better. And I will like to see if I see some buffering in the stream. That would be cool. And let's just begin solving questions. And here I was doing something with trying to do something with pointers. Yep, let's begin. The CP31 worksheet or sheet of questions, and the next question is and sequence. Let's go to stopwatch. We'll start a stopwatch and begin doing the question. Problem statement seems to be small. Let's see. Okay, we have and sequence and we can begin. Wait, I have to set up my tmux first. I will kill everything in my tmux and set, which runs a custom tmux script to set the sessions. And now tmux attach and target is CP, competitive programming. And start new vim. There are updates. Okay, cool. Packages have been updated and we can begin. Let's see. A sequence of n non-negative integers, n at least 2, is called good if from 1 to n minus 1 the following condition holds, and of everything ai a1 a2 and of ai1 plus ai2. Okay, left they are equal, where this denotes and you are given a sequence array a of size n, right, greater than 2. Find the number of permutations p of numbers ranging from 1 to n for which the sequence this is good. Since this number can be large, output this. Okay, and has to be equal for every integer, and I will have something on the left and something for on the right. Okay, for every index I would like to find the number of permutations, and the number of permutations, the order of these here does not matter. Yeah, there will be some bits on here and some bits off. If I have a 0, I would like to, as here I have 2 zeros, so I would, yeah, my and would never be greater than 0. It would be 0 in both the things. So at the first index, I can only have a 0 here on the left, and on the right, I can permute these 4 things, which is 4 factorial, and then when I'm here, I would have 4 choose. Okay, but the 0 is same. The 0 is same, so 4 factorial divided by 2. That would be 4 into 3, 12. 12 when I equals to this place, I is here, and when I is here, then I would like to have 1 0 on the left and 1 0 on the left. I have three possible options for the zeros, but that does not matter. All of them are same. So, okay. And the place that is not zero, for that I have three choices. So 3 into, for here, the permutation would be one thing is 0 and the other two are not. And for the other two, I have three choices. I have two choices because among the three, one was chosen there. Hmm. So I guess the thing would be here 6. Okay, let's go to Excalibur. Combinatorial. I have this. And what can I do with this? I have 0. In binary, it is just 0. For 2, it is 1 0. For 0, again 0. And for 3, we have 1 1. And for 0, we have 0. And I hope the stream is not lagging, and it is not. That is pretty cool. Nice. Hello. Error. Shit. You need to change the video resolution. The current resolution is this, which is not supported for this configuration. I but I do not see in my OBS any errors. It seems fine in OBS, and I hope it is actually fine. Yep, seems fine. Seems fine. Yep, that is very low latency. That is cool. Okay, so here I've done a question like this in which I had to, yeah, in which I had to find prefix of binary numbers in which the index would represent the bit, the number of bits, the number of 0 bits I have seen till this element in this array, and 1 would represent the number of 1 bits, the number of bits at index 1 till this current element, and like that. But here, since I want to divide this thing into two different things, how many permutations I could have? I have 0, 2, 0, 3, 0. And what can I do with this? Let's write down the bits, the ones that I have, and the number of them. Here I am using at most 2 bits. Yeah, 2 bits, the 0th bit and the first bit. And yes, how many 1/0th bits I have? I have only one in the 3, and I have 2 bits at the first index, and in total I have 5 elements. So to make the permutation on both the sides equal, I need to divide these things into groups of 2. Not into groups of 2, but okay, yes, fuck, yes, okay. If my index is, if my element size is 5, if my element size is 5, then I will start, let's say, one indexed from 1, and I would have one element A1 here on the left, and elements from A2 and A3 and A4 and A5 on the right. and I will check for every bit. Yes, for every bit. Let's begin from the 0th bit. I will see that there is only one of this 0th bit, so I would not like to keep it here, right? Because if I want to keep this 0th bit on this side, I do not have enough of them to have it on the other side for every number I see here, right? So, nope, my answer would not have the 0th bit, and that would actually give me some constraints. I have this one number that has this 0th bit, and I would not like this number to go into A1. So, how many choices do I have here that I would like to see? Well, I have in total 5 numbers. I cannot have this one number that has one bit right here. So 5 minus 1, I would have 4 choices that could go here, right? And then on the right, yes, and then moving on to the next bit, the bit at index 1, I have two of them. And if I have two of them, if I want to keep this, then I would like to distribute them on both the sides, but I do not have enough. So I would not like to have these numbers with the bit at index 1 to go into this place, because that would make this bit up, but I do not have enough of them to make the bit up on the right hand side. So I cannot choose this, but this is double counting. This is double counting. How do I find the number of choices? Because if I add from my current choice the number 2, that is bad, because I would be removing 3 as a choice from the numbers that could go on the left when I equals 1, but I have already removed 5 when I was checking bit 0. I have already removed 3 when I was checking bit 0, the 0th bit. So I need to make sure that I only remove the bits what I need is the number of elements that could go on this side. Here I have, well, first of all, I would have the size of the array on one side. Let's say here size is 5. I will have 5 elements on the right, on the left, and total elements are n. And what I need to know is how many of these n elements are eligible to go there. And in this case, the size here is 1, and the number of elements that could go here is 3. So in total, I can have, this is all I have, and so something like the permutation for choosing one things from 3, that is 3 factorial divided by 1 factorial, that is just 6. Huh? 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 No, shit. Divided by 3 minus 1 factorial, 2 factorial. That is 3. 3 on the left, and on the right, what is the number of choices that I could have? On the right, the number of elements I need to have is 4. And what is the number of eligible choices that I could have? What is the number of eligible choices that I could have on the right? Well, there are some elements that I need to have here. I need to have at least 1 0. Combinatorics. Okay. I have in total 5 elements, and when I equals 1 on the left, I need to choose one element, and among these five, 3 are eligible to go there. And on the right, I need to choose 4 elements, and how many can go there? I think this is not the right way to think about this. There might be something else. Yo, hello, how are you? And is the stream okay? You need to change. Wait, maybe the video resolution is not pretty cool. Sh- Wait, let me just see, and it is cool actually. Yeah. Yeah, it is fine. It is fine. It is fine. Because I changed some settings to reduce the latency, and it seems to be fine. Okay, in this question, this is the question I'm doing right now. B and sequences. So, okay, at least I know which bits I can have on or off. Yep. Okay, so some bits, yes, okay. Again, I can know some bits that I would like to have. Wait, the bits that are on would always be on, would be on in all the numbers. So I would not care about them because, because yeah, yep. The bits that are on would be on for all the numbers in the whole array. So I do not actually care about them. I only care about the bits that are on in some places, in some numbers. So at index 0, index 0 would be off, and index 1 would be off. And I have one number which has one bit at index 1, and I have here two numbers which have one bits on at this place. And all I need to see is that this one number does not go there, and these two numbers do not go there at the same time. Even though the number that has this one bit and also on bit at index 1 is the same number, which is 3. I also need to take care of double counting in that sense. So, so in respect of the 0th bit, I have 4 possible choices, and in respect of the 1 bit, I have 3 possible choices. But that is not correct. That is not correct. I do not know if these 4 and how these 4 and these 3 overlap. And I need both of these to be 0 at the same time here. The answer for the left side is 3, that I do know as a human being. But how do I know that? I need to create a formula. What I need is the 0th bit and the first bit to be 0 on this side and also on this side. And I have one number that has its 0th bit on and two numbers that have their first bit on. And in this case, they overlap. This one number is also included in these two numbers. But if I had just this and the number that was on in both the places was the same number, that is 3. Okay, maybe this model is not correct. This would need a vector of size 32, 31 unsigned, 31 because it is signed. It feels like I can just grab the solution. I am just there. Okay, to make these 2 bits 0. Okay, go, let's write the whole thing. Let's say I am using 8 bits. My word size is 8 bits. So I would have 3, 4, 5, 6, 7. And the 0th bit, I have one number that is on, and the first bit, I have two numbers. At the second bit, I have 0, then 0, then 0, 0, 0, 0. The only thing that is confusing or that is making this hard is that these overlap. These things overlap. Or if I nah, if I count the number of numbers which have this bit equal to off, that wouldn't help much because that I already know. I just need to do n minus this current number 1 and I would get 4. The number of things that have this thing equal to 0. Okay, let's read how they are calculating answer for one of these. The first test case, since all the numbers are equal, bruh, bruh. There are total 6 sequences, permutations with the numbers. Whatever permutation we take, the sequence is good. There are in total of 6 permutations. Okay, okay, this one is different from this one. Okay. Okay, permutations. Okay. We have to make permutations of the indices. Okay, makes sense. This permutation is when I is at this place, this permutation, and this is good for I equals 1. This is good. 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 Okay, what do we actually have to calculate? The following condition holds true, then, okay, you are given an array. Find the number of permutations P of numbers. Okay, if this thing holds for all of them, it changes the question. It changes the question. Okay, shit, it does change the question. I misread the question, and this thing does change the question. A permutation is good if this thing holds for all the I, ranging from 1 to n minus 1. I thought it would be considered good if it holds for just one eye, but it has to hold for all the eyes. So that is cool. That is cool. And all I need to count is how many numbers have this bit, any particular given bit, equal to 0. And initially it will be equal to n. That is, all the numbers have this bit equal to 0. And whenever I see a number which has this bit as on, I will reduce 1. So in that sense, when n equals 5 for this particular test case, let's say we are just using 4 bits to represent our number. 4 bits would be till 3. So we would have, and the permutation, the question was this. This is the test case. This for 0th bit, 1 bit, 2 bit, 3 bit. And how many numbers have this 0th bit equal to 0? That is 4. And there are 3 numbers which have this thing equal to 0, and n 5 numbers which have this 0, and 5 numbers which have this 0. Yep. So permutation is good if this holds for all the numbers. Well, if it has to hold for all the numbers, wait, if it has to hold for all the numbers, then if there is one bit that is 0, I do not care about it. Let's say I have 5. Okay. This also does not matter. This also does not matter. Shit. I think the answer would be same. No matter the permutation, the and, I'm basically taking the and of the whole thing. And yeah, I am taking the and of the whole thing. So yes, I'm taking the and of the whole thing. And when I take, okay, while I'm taking the input, I can take the and of the whole thing. And then I need to find the numbers that are equal to that and from this thing, from the given array. In here, the total and would be equal to 0, and I have 3 numbers that are equal to that and. That would mean I need to have at least one of them on the left, one of them on the right for a permutation to be good, and everything in between can change to whatever order. Yes, whatever order they can change to whatever order does not matter, because I have made sure that this would always be true. Yes, this would always be true. So let's say I have 3 choices, and yes, I have 3 choices, and the number of ways I can choose 2 things from 3 in sense of permutation. This is not combination. So 3 factorial divided by 1 factorial, it would be 6. 6. There are 6 ways to arrange this, and for every way there would be, since I have chosen 2 elements for every way, there would be 3 elements remaining. That is n minus 2 elements, always 3 elements remaining, and the permutation for 3 elements is 3 factorial. So 6 into 3 factorial, which is 6, equals 36. And is 36 the correct answer for this one? God damn, it is. Yes, okay, that is cool. That is cool. That is cool. And what is the permutation of this thing? The and of this thing is 1. Ah, cool, cool. Okay. The and of the whole thing is same. The and of the whole thing is same. And yes, I have to take the and of the whole thing and then find the numbers which are equal to that and put one of them on the either side. Find the number of ways I can choose those elements to put them on either sides, and multiply that by the number of ways I can rearrange the elements in the middle. That seems correct. That seems correct. That actually seems correct, because I ranges from the 1 to n minus 1. That would mean at one point this has to be good when this thing, I am only taking and of this thing. So this thing has to be equal to the and. Okay, okay, that makes sense. That actually makes sense. Hello. And yeah, so somehow I feel like there is this error. And if there is some mishap or some difficulty in uh, some buffering or lag in the stream, you could please tell me. It would be really nice if you could. And I can write the solution now. Okay, that is cool. That is cool. That is cool. That is cool. That is not just cool, it seems elegant. Okay, not Python, RM, RF, everything that starts with .py. Now, start new vim, and I already have some updates. C++. And yep, n is fine, but I can be really big. And I would also like to have modulus 1e9 plus 7. Vector is long, a side n, ai, and ll, nd, which is initially equal to int 64, 64 max. And here nd and with ai. That is cool. And now I just have to see how many numbers are equal to that and xna, if, or wait, I can just do call the count function, and cnt equals count a dot begin, a dot end, and what count the occurrences of nd. Now the permutations for choosing 2 from cnt. Now if cnt lower than 2, then cout 0. Like no way we can do this. Else, if that is greater than 2, hmm, response equals 0. Factorial, I would have to find a factorial function and wait a minute. I will be right back in a minute. And I'm back. And we can go back to doing our question, which is cool. Yes, so we have the number of things that are equal to this. I would like to also create a factorial function, which would find the factorial. It would return a long fact. It will take a long number n and just if n equals 1, returns 1 and else return n into fact of n minus 1. LL rest equals 1 and for n I equals 0, I less than I equals shit, while n rest multiply equals n and n minus and rest remainder equals with capital M, even though it is not defined at that point, and at the end return rest. That should work. I don't even need this. Yeah, cool. And yep. So what would I need here? I would need the factorial of the whole thing, factorial of count divided by, so factorial of count, I would need factorial of count divided by, okay, factorial of count, CNT factorial divided by count minus 2 factorial. Yeah, rest equals fact of CNT divided by fact of CNT minus 2. And CNT is either equal, what is factorial 0? Makes sense. Factorial 0 is if n, if not n, return 1. If not n, return 1. Result and factorial n, okay. Result, right. I have the thing, the number of ways I can have things on either end. And now I need to find the number of ways I can have the things in the middle. That would be equal to factorial of, so mid is factorial of n minus 2. Right, and just multiply the two, multiply by equal to mid and rest remainder with n, we have rest new line. Okay, okay, that seems to be correct. And now the trick that I have discovered is, instead of going through the whole thing and finding out is there a bug, and since this is not a official contest and I'm just practicing and I want to become better at competitive programming. Just delete the whole thing and write everything from scratch. Int n, c in n, and vector long a size n for auto reference a, c in x, but no, that is bad. Int I equals 0, I less than n, I plus plus, and I would have ll and equals int 64, 64 max c in ai and equals AI. Take the and with AI, and I would also need my factorial function and const int m equals 1e9 plus 7 const and return factorial fact taken n, and if not n return 1, and else res equals 1 for int I equals 1, I less than equal to n, I plus plus. What I want is res multiply by equal to I, but also on the other line, next line, take the remainder modulus and then return at the end result. And now when I have the and int count equals count a dot begin a dot end, we are looking for and now if cnt lower than 2, return or not return but see out 0 new line, and else if that is not the case, then int result equals factorial of cnt, yep, factorial of cnt divided by factorial of cnt minus 2. And now, or maybe long would be better, just in case. Long mid equals factorial of everything that we didn't choose, that is n minus 2. And now let's multiply by equals to mid, multiply the 2. Yep, multiply the 2 and then take modulus with m and see out the result. Cool. You can just submit this and let's see if this is correct. I think this is correct. Wait, shit. No. Hmm. That is absolutely wrong. I copied the wrong part. Yep. Compilation error. Yep, makes sense. Wrong answer on test 2. Wrong answers on test 2. So we missed something logically. Wrong answer on test 2. Wrong answer. Wrong answer. Was it error? Uh, Error in like long or in that sense? Okay, it was just a wrong answer. Okay. So there is some flaw with our logic. Find the and. Would there be some way in which the total and is not equal to that thing? Okay, I'm taking the total and, right. Maybe this thing is wrong. Let's unsign int and make this int max 64 or a bit set of 32 bits. A bit set of of 31 bits. Bit set of size 31, 31, 31, 31. BS. Initially, everything is or int ND, and then Cn, not the Cn A0 and ND equals A0. Right, initialization is now cool. I'm thinking that was the error. That was the error. No, maybe shit, no, that was not the error because everything was equal to 1 in int 64-bit max, and after taking AND for the first time, only the bits that were equal to 1 in A0 were equal to 1. So this does not really change anything. There is some other logical flaw in this. Count. 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 May does not make sense. Does not make sense. Okay. Yeah, shit. No, I think my approach is wrong, but somehow no. I think my approach is correct. It is giving a wrong answer though. Do I understand the problem statement correctly? A sequence of n non-negative integers, right? N is always greater than or equal to 2, is called good if for all I 1 to n minus 1, right? And on the left side is equal to and on the right side. For all I, right? So for this thing to be equal, the and my hypothesis is that this and equals the and of the whole thing. That is my proposal. Yes, because and on the left side, if it is equal to and on the right side, then if I take and of these, all of these things with the numbers, and with the numbers on the right, the whole and would be same. So when I have only one number on the left, that is a1, and only one number on the right, that is an, when I equals n minus 1, in that case, I must have an and ai equal to the and of the whole string, and that is what I'm doing. I'm taking and then I'm counting how many times do I see this and in the whole thing, and if that count is lower than 2, I cannot have it on both the sides, so that is wrong. Else, if I do have it, then this is the formula. This is the number of ways to choose those two endpoints given the count. Yes, that is correct. And then this is the number of ways to arrange the things in the middle and multiply them together. So, yep, that should have worked. That should have worked. And I'm also taking modulus with this m, and here also I'm taking modulus. But clearly something is wrong with this somehow. No, no data is actually crazy. Poor. Okay, no data was at the start. Is the stream right now okay? Yeah, stream is okay. Stream is like absolutely okay. That is cool. That is cool. And there is also the lag. The lag is really low right now. So that is also cool. almost real time, I would say. Okay, so somehow answer is wrong, even though the logic seems absolute. Yeah, my hypothesis is that something is wrong here. Is it the fact that I'm returning a long? I don't think so because here I am taking the modulus before returning the long. And yep, here also there are zeros for some answers. So I got that part also correct. Okay, I'll think, let me think about this more a bit and then we can look at the test case in which I got the wrong answer. But I don't, yeah, like does not matter if I think this logic is correct because I'm getting the wrong answer. So something is clearly wrong with this resolution, response, fact, begin and right. I can begin initialize this with this uh, with int is fine, long is also fine, right? And taking and is not really bad. Taking and only reduces the number. I'm taking and of all the numbers here and then I'm counting the numbers in the given array which have this and yep, which are equal to this and then count. If it is lower than 2, then output 0. I cannot have any good sequence, right? If count is 0, nope. If count is 1, then also no. If count is 1, yeah, then also 1, no, then also no. And else rs equals fact, the number of ways to count, to take factorial of cnt and divided by factorial of cnt minus 2 because that is the number of ways to choose two things, number of permutations to choose two things from a given count cnt, right? I hope my formula is not correct, is correct here. For finding factorial, is my formula wrong? Permutations, I need to choose two things out of n things. Then the formula is it 2 factorial or n minus 2 factorial? I think it is n minus 2 factorial, and that is what I have written. Fact of this thing divided by fact of cnt minus 2 because I'm choosing two things. And we can even take an example. 6, no. If I have two things, then factorial 2 divided by, with this formula, it is 1, and that is correct. Okay, with 3, if I have three things, the answer should be 3, but I am also considering the permutation. So, answer, wait, answer here should be 2 because I'm choosing two things and there are two ways, A, B, B, A. So, answer should not be 1, that is wrong. So, answer is this, yes, n minus 2 factorial and here n is 2. So, 2 factorial divided by 0 factorial which we are taking as 1. So, 2, that is correct and that is what I'm doing. Therefore, this formula is correct. And then the number of ways to choose the things that were not chosen, that is n minus 2 factorial. And then multiply the two things take the modulus and return. That seems impeccable. That absolutely seems impeccable. Okay, let's see, look at the test case in which I got the wrong answer. Even though it is not right, but since we have to move forward, let's look at it. It says wrong. Shit. That there is some difference. Found a smaller number. They were looking for a larger number. And the fifth test case. 1, 2, 4, 5. Here. Okay, so this should have been cool. This should have been cool. Clang, bang, sequence, only one test case, and no, I have 16 things. Yes, I have 16 things, and those 16 things are all 17. What does my code say? My code says this, and okay, my code says this. I have 16 things, and from those 16, I need to choose 3. That would be 16 factorial divided by 15 divided by 14 factorial. That is just 16. 16 into 15, and 15 is the number of pairs and 16 is the other thing. 16 into 15, that would be 240. 16 into 15, and yep, and then divide this, multiply this by 14 factorial. Now what is 14 factorial? It is a big number, this whole number. This big number. Now if I divide this big number by 240, I get a very big number, and I need to take its remainder with 1e9 plus 7, and that is that. Okay, so I messed up. My code is clearly messing up at some point. Let's output rest, and then output mid. Yep, let's do that. One test case, 16 things in the test case, and those 16 things are 16 17s. 4 is clearly wrong. 4 is clearly wrong. The other number might be correct, but 4 is wrong because 16 factorial divided by 14 factorial. Let's also see CNT count. One test case with 16 things, and those are these things. Okay, 16, and we are finding that 16 factorial divided by 14 factorial turns out to be 4 somehow. which is wrong. It should be 240, 240, 240. And if we manually do equals 240, will we get the correct answer? 16 and copy. Okay, we do get the correct answer. So we are somehow getting the result wrong. Fact 16, and let's do rest divided by equal to fact not 16 cnt fact cnt minus 2. Yes, yes. Line got slashed out. One test case with 16 numbers, and the numbers are these. And still, it is wrong. Why do I see 16 here? This 16 is the count. Okay. The factorial is wrong. The factorial is wrong. I think it is because of modulus and modulus division. It is because of modulus division. Yep. P, in total, I have CNT things and I need to choose two things from CNT. Let's write this. Perm. This will return the number of permutations, return a long. Perm takes n, and let's say k and res equals 1, and both of these are integers. And then I will start a loop from for int I equals k. Nope, for int I equals n minus k. N minus k plus 1. N minus k plus 1 till I less than equal to n, and I plus plus res multiply by equal to I, and res modulus with m, and then return res. And now we should be pretty cool. And the series of 17. Yep, that is correct. That is correct. And the mistake was that in modular arithmetic, division is different. You cannot just divide stuff. To divide stuff, you would need the inverse of the number. And you do not want to do that. You can just find some other way around. And even if you want the inverse, you can find the inverse. That takes a long time. So you would not like to do that. Accepted. That is cool. It says here accepted. It is running and it is accepted. It took 1 hour, even though it seemed straightforward after some time, but okay. Anyways, was it educational round? This thing, was this an educational round? I think it could be. Hmm. Nope, it wasn't, but it is divide by 0 or something. Okay, that is cool. We can refresh. But before moving on to the next question, we would like to go to the tutorial of this thing, and I would like to predict the tags. And in the tags, I predict that I would see modular arithmetic, I would see maths, combinatorics, because we are using permutations. Yeah, maths and combinatorics. Yeah, bit mask, combinatorics, and maths. Constructive algorithm. Yeah, okay, cool. So the main thing that we had to know is that this and is going to be equal to the and of the whole array. And yeah, after that, it was just applying some mathematics. Let's see the tutorial. B, question number B, and sequences. Okay, it was division to second question. Okay, second question 1400 rated somehow. Ajit, consider an arbitrary sequence B1 till Bn. First, let us define the array and wait, the same question, right? And sequence. And sequence, it is the same question. Prefix, okay, let's let him cook. And prefix and suffix of length n, where pref equals b1 and b2 and all the numbers in b, and suffix equals this and of the other things. Okay, that's cool. According to the definition of good sequence, pref of some number equals suff of the other number. Okay, okay. Suffix of the next number, okay, makes sense, which means b1 equal to yes, now, and prefix 2 less than equal to and prefix 1 less than equal to and prefix 1. Yes, because we have one more number, we would be considering one more number. Okay, and this thing, and prefix 1 equals prefix 2, which is less than equals to prefix 3. Suffix 3, it is less than equal to suffix 3 because suffix 3 has one less number and it starts from here. Okay, also according to the definition of good sequence, pref 2 equals suffix 3. That means b1 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 equals and of prefix 2, that is and of the first two numbers, and which is equal to and of suffix 3 because this thing. So b1 equals to this thing. Okay, similarly for all i's we get this thing, b1 equals to the prefix of all the numbers and b1 equals to the suffix of all the numbers. Therefore, for sequence this to be good, b1 equals to bn and bi must be supermask of b1 for all I from 2 to n minus 1. Supermask. Okay, I do not know what a supermask is. Initially, we have an array this, let the minimum value among these elements be x, let the number of elements have the value of x, b, c, and t in order to rearrange the elements. Okay, smallest number. Okay, in order, smallest number is not cool. Choosing the smallest number is not cool. We need the number that is equal to the and of the whole array. In order to rearrange the elements a1 to an to a good sequence, we need to have CNT greater than equal to 2, and the remaining elements need to be a mask of x. If we don't meet this criteria, then the answer is 0. Else the answer would be this. Huh? Oh shit, that is much better. Shit, that is much better than what I am doing here, using a full-fledged function to find this thing. You would have CNT into CNT minus 1. Yep. And then rest remainder with M. Yep, cool. And multiply that by n by 2 n minus 2 factorial. Okay, cool. Cool. That is cool. That is exactly the same thing that we were doing here. But it is different in the sense that I am first finding the end and finding the number that gives me that, and that number is going to be the minimum number. And that makes sense. But this terminology uses a thing called supermask. Supermask. Okay. Let's look into what supermask is in bits. Or maybe I can look at what supermask is afterwards. Supermask and superposition, that is crazy. Okay, later. Now we can move on to the next question. Reset our timer. It took me 1 hour to do one question, but fine. Our rank is under 700 now. Okay. Ball in Berland. And Berland is the same thing we had here. That is cool. And now moving on to the next question. And the lag is amazing. I mean, there is no lag. Lag is just for at best 7 seconds. Stream status is poor. Poor. Serious issues that need attention. Okay. Good minor issues. Because I have changed the latency. And if the stream is bad, you could please tell me. It would be really nice if you could. To me, it seems perfectly amazing. Like right here, when I'm looking at the stream, it is perfectly amazing. And if there are some issues in the stream with you guys, it would be really nice if you would tell me. And also, the lag is not that much because I changed the latency is not that much. Earlier, it was normal latency. Now it is on low latency, and I am trying to see if this thing works. That's cool. And let's move on to the next question. Ball in Berland takes 2 seconds. Okay, cool. Let's go. At a school where Vasya, okay, is studying, preparations are underway for the graduation ceremony. One of the planned performance is a ball which will be attended by pairs of boys and girls. Each class must present two couples to the ball. In Vasya's class, A boys and B girls wish to participate, but not all boys and not all girls are ready to dance in pairs. Formally, key possible one boy, one girl pairs. Formally, okay. You need to choose two of these pairs so that no person is in more than one pair. I need to choose two of these pairs. For example, if there are three boys and four girls, bipartite graph, I have three nodes on one side, four nodes on one side, and k k pairs. I know k pairs. That is k edges, and the couples 1 2 1 3, edge between 1 2 1 3, and edge between 2 2 and 3 4. I could choose 1 2 and 3 4. That would be nice. Are ready to dance. In each pair, the boys number comes first, then the girls. Okay, misogynistic. Then the following combinations of two pairs are possible, not all possible. 1 3 and 2 2, is possible and this is possible, but the following combinations are not possible because boy 1 cannot be with girl 2 and 3, and same for girl 2. Find the number of ways to select two pairs that match the above condition. Two ways are considered different if they consist of different pairs. Find the number of ways to find two pairs. Okay, that is just a bipartite graph, and I need to find stuff. Okay, what do we get? We get A, B, and K. A, B, and K, the number of nodes on the left side. On the right side, K is the number of edges. Then I will have K and K. Okay. Now, how would I like to represent this, and how would I like to go through? Um, okay, I have some stuff, some nodes on the left and some nodes on the right, and this is a bipartite graph. I have some stuff like this, like so, like so, say this, and here, let's say I want to choose this thing, and I can, okay, let's say when I'm choosing this edge, what are the number of edges I cannot choose? The number of edges that I cannot choose, I can choose any other edge. I can, let's say there are k edges. When I'm choosing this edge, I can choose k minus 1 other edges. So the number of pairs when I'm choosing this edge is k minus 1. And now plus, when I'm choosing this particular edge, I can choose any other edge because this one does not share anything with any other thing. But when I'm choosing this particular edge, I cannot choose one edge here. Yeah, this is the only edge I cannot choose. Let's make this a little more complicated, maybe like this and then this. So here, when I'm choosing this particular edge, I cannot choose this edge, remove one, and I cannot choose this edge. So k minus 2 number of pairs would be possible, and that is cool. That is cool. That is cool. Remove everything else, just keep the mathematics in the question, and you will get the answer. A, B, and K. C in A, B, B, K. And what are the limitations? Limitations are fine. How would I like to store this? I would like to store this as a bipartite graph. What the heck does that mean? I would like to store this as a adjacency matrix. Adjacency matrix. So VI AE edges with A edges, yes. And how many would be there? A. And VI BE, there would be point I equals 0, I less than K, I plus plus, and okay. And what is the thing? This thing, AI is the number. A, yes, shit, not K, but A and then B. AI is the number of the boy in the pair. There are I pairs. How can I have this many pairs? K is the number of pairs. The test case contains K integers. The values, okay. Okay, K is correct. So in the ith pair, the boy is, this is the boy, and see, how do I convert this into a adjacency matrix? Adjacency matrix. I have something like this. I want to convert this into an adjacency matrix. Okay, yeah, it is fine. It is fine. It is fine. It is fine. VI boys or A AE size would be K, since I have K edges, and I can just take them AEI, and then for int I equals 0, I less than K, I plus plus. What we have is int, take this into C and put this into our vector VI ADJ of size. How many edges do we have? We have K edges, but shit, that is not really cool. Uh, yep. What I can do, what I can do is, yeah, VI CNTA size A. C in C. C is the number of the boy that is in a pair. How do I know? So count would not work. Count would not work. I need to store these edges. I can just store the edges. Okay. CNTA bracket C plus plus and plus 1 and VI CNT B A plus B plus 1, remove this, taken, and CNT B C plus plus. I have the number and I also need the edges, and that would be a vector of pairs of integers called edges of size k, and that, yeah, cool. Okay, so for this pair, this C, I would have edges bracket I dot first equals C, and here the same thing for second. And now I can iterate through for int I equals 0, or for auto I comma j in edges. I is the index of the boy and j is the index of the girl in this particular thing. And answer could answer be really big? Do I have to take the modulus? I do not have to take the modulus. Let's anyway, resolution response equals. So for this particular edge, what do I have to add? I will have k minus 2, k minus 1, because I am using this edge. And now how many other edge do I have to exclude from this? That would be CNT A I, CNT B J. I have to do some ground matching here. CNT A I gives me the number of edges, gives me the number of nodes that the ith node in the first group is connected to. And since one of them is right here, so minus 1, and the same thing here, minus 1. And this should work. A bipartite graph, and that is not what I was expecting. Okay, 16, 0 to 20. That is very, very high numbers. Am I taking them in the right order? A, B, C, A, B, K. Then count vector edges. Yep. In the ith pair, the first thing is this. In the ith edge, second is this. Correct. That is correct. And CNTA is connected to this much stuff, and CNTB C is connected to this one pass. The number of pairs to which this thing is connected to. Okay. Let's do this for this. Here I have this 3 nodes on the left and 1, 2, 3, 4 nodes on the right. And when I go through, what I'm counting is what I'm storing is 1, 2, then 1, 3, then 2, 2, and then 3, 4. Those are the edges that I'm storing. And here for the first one, this its value is 2. For this one, value is 1. For this one, value is also 1. Here, the value is, wait, here the value is 0. That is very not cool. Here the value is 2, here 1, and here it is 1. It's 4 edges in total. For the first edge, I see the number here is 2, and the number here is 2. So when I am choosing this 1, 2 edge, I cannot choose 2 other edges. Yes, I cannot choose 2 other edges. That is cool. One other edge from this, one other edge from this. In total, I have 4 minus 1, 3. 3 answer would be 1 would be added to the answer in this case. K minus 1, K is in this case 4. So K minus 1, 3, and from 3 subtract 2 minus 1. Yeah, that is cool. That is cool. That is cool. 2 minus 1 and 2 minus 1, that is 2. So plus add 1 to the thing. Let's see this in action, or maybe here CNTA, then CNTB, and then overload. Not this thing. Blank plus plus. The name here is wall in Berland, and I have only one test case which has this much stuff. One test case which has this much, and 1, 1, 2. Okay, that is actually cool, and that correct. So what is the problem? Double counting, not just double counting. I'm counting it. Yeah. Yep. Yep. I am counting them multiple times. Hmm. Hmm. I'm counting the same thing multiple times. That makes sense. That makes sense. That makes a lot of sense actually. I have on the left 1, 2, 3 nodes, and on the right 4. Yep. And these two are connected. These two are connected. These two are connected, and these two are connected. Yep. When I am choosing this as one of the edges, I'm also choosing this as the other edge, and when I choose this as the other edge, I'm counting this again. Mm, Yep, so there is a overlap which I need to fix. Yeah, when I am at this thing, I know that for some particular edge, I would have to subtract 1 from that. Not just for one particular edge, for how many edges there are, which I counted. From them, I would have to reduce 1. Right. Yep. And then when I'm here, no. I only care about what comes next. So that changes things. That changes things. That changes things. Counting. I need to fix the counting. Prefix? Yeah. Um, okay. Okay, maybe I can do this while I am taking in the edges. Yes, I can do this while I am taking in the edges, so I do not have to do this. This, read the response right here. And when I have taken this particular edge, let's say in no, auto x comma y equals edges I. I have the I edge fulfilled, and rest plus equals k minus 1. And from this, subtract the number of edges x minus 1. No, cnt cnt a x minus 1 and cnt b y minus 1. Okay, why do I have a comma? I should not have a comma, but I should at least have a plus. Let's see. I think that should work. That should have worked. That should have worked. But this is much better than before. Result 0. And the idea here is that when I see this edge, what do I add? I do not add anything because I do not have any other pair to go through with this. Among the pairs that I have seen till this point, 1, 2, 1, 3, 2, 2, and 3, 4. So this will work in the order that I see an edge. When I see this edge and I haven't seen any edges, so I would add nothing to the response. And then when I see this edge and among the edges that I have seen till this point, there is no edge that can go with this edge. So also 0 would be added. And when I see this edge, the edges that can go with this is 1. So I should have added 1. And then when I see this edge, the number of edges that can go with this edge is 2, 1, and 2. So answer should be 3 in total. Is the answer for this thing 4. Okay, when I have this thing can go, this thing can go. When I have this, actually this thing can go. And when I am here, nothing can go. from the top. Yep, when I am here, nothing can go from the top. When I am here, this can go. So +1. And then when I am here, this works. And this also works. 2. Should be 3. Oh, what are the 4 possibilities? 1 2 1 3 2 2 3 4. 1 2 1 3 2 2 3 4 are ready to dance together, but the following are not possible. 1 3 and 2 3. 1 2 3 4. Yes, for 3 4 there are 1 3 1 3 1 3. Yes, 3 is here in this case and 3 is there in that case. Okay, so 4 in total. That is correct. So why does my result not reflect that part? Makes sense because I do not have the total count. Makes total sense. Makes total sense. So instead of k, I should have I plus 1. That is the number of edges I have seen till this point. I is actually the number of edges that I have seen till this point. Nope. For the first, I have not seen any edges. So I. 3 and 4. I among I. Why do I subtract? Why do I subtract? CNTAX. I have updated CNTAX and I have updated CNT. Yes, CNTAX and CNTB both have been updated. Ball 1 3 4 4 and 1 1 2 3 2 3 2 4. Yep, -1 is a problem. It would have been pretty cool if it weren't for -1. Yeah, -1 is the problem. When I am at 0, this thing would be 0. And what would I have here? I should have had 0 for both the things because this would be 1, would have been 1, and this would have been 1. Which is I. Okay. Okay. Okay, makes sense. Makes sense because the boys part is already fully updated and the girls part is not. Makes sense. Hello, how are you? And let me go to the washroom. I'll be right back. Like, I got a pee. Nope, totally back. And hello again. Prism X. Yep, just drink water after going to pee. That is pretty cool. And yeah, so what I need to do is just store the edges and not care about other stuff. Edge, yep, store the edge there and simply store the edges. Yep, I don't even need this. For int I equals 0, I less than k, I plus plus cn edges dot I dot first and edges I not first but this time second, and my vector would also be there. Now int I equals or auto x comma y in edges long response equals 0 and cnta bracket x plus plus and cntb bracket y plus plus and rest plus equals I from I subtract cnta x minus 1 plus cnt b y minus 1. I is not there makes a lot of sense. I plus plus just on the next line. See out. Not here. Here, check here, check. And that is correct. That is correct. That is correct. And what I would like to do is delete the whole thing and write the whole thing from scratch again. A, B, and K. Those are things I have. K is the number of edges in this thing. And the things I need to store are vector, pair, int edges, size would be K, and CNT vector CNTA count of A till now A plus 1 and VI CNT B plus 1, and for int I equals 0 I less than n I plus plus Cn edges I dot first, and for int I equals 0 I less than n I plus plus n is the wrong thing. That is just muscle memory. Instead of n, I should have k, and after that, I just need to go through the whole thing for int I equals 0, I less than k not n, I plus plus, and we can do auto x comma y equals it is I and rest plus equals I minus, or before that cnt a bracket x plus plus and cnt b bracket y plus plus, and here cnt a bracket x minus 1 plus cnt b bracket y minus 1 minus 1. And what is rest? That is a good question. Rest is 0, and here we have returned a rest. The response and the answer should be correct, and it is correct. Okay, are there any logical bugs apart from the implementation? And I think not. I think this is correct. Let's try to submit. Let's see. Hello. Will you stop CP after reaching 2000? No, I think I will keep doing contests, and it is actually cool to see someone else say that I will reach 2000, not that if I could reach 2000. Okay, that is accepted. Yeah, thank you for saying that I will reach 2000. How did you figure out it is graph? Okay, there's one really cool thing that I would like to share. Code forces, and if you go to education, or where was it, catalog, how to come up with solutions. Here, if you go to this thing, how to read problem statements. In this, there are some basic rules, and one of the rules is the result of reading the statement is usually pure math model. If a story helps to build correct understanding, you can keep it, but try to discard as many unnecessary details as possible. What does this mean? It means that when you are reading a question, remove everything else. You could see that while I was solving the question, I was only referring to this thing in terms of a graph. I was not like, maybe I was at times referring to this thing as pairs between boys and girls, but in my head, the model was a bipartite graph, and you just have to read things. I knew that I had a certain number of boys and girls, but in my head, I was thinking, okay, I have some things here, I have some things there, and I know these boys, I have some things on one side, and I have other things on other side, and these things are connected like this, so seems like a graph. And yep, remove the story and just keep the pure mathematical model. So yeah, you can read this, you can read this. This is actually pretty cool. Hello. And there was another one here by Mr. Mike. It was how to come up with a solution. Yep, this one, 10 years ago by Mr. Mike. And this one was also pretty cool. Rent to look. Wait, I think I haven't read this whole thing. Yeah, I haven't read this one. But I read this one. This one was pretty cool actually. Yeah, all of these things are cool. Binary trees. Shit, I haven't read a lot of these. I haven't read anything from this. Yeah, yeah, you can read this. This is cool. Catalog. Go to catalog. That is cool. Now moving on to the next question. This one took 32 minutes. Refresh. And now we can move on to the next question that is refreshed. And then we have done 2 questions till now, which is fine. Not really bad, but not really good. Zero remainder array. And it has been 1 hour and 48 minutes. Refresh the timer and drink some water. And this is poor. And I would please like someone to tell me if the stream quality is actually poor, if there is something wrong with the stream. Maybe the quality should be 2K, and if it is 2K and it is not lagging, then cool, that is cool. Stream is good, that is cool, that is cool. YouTube is just scaring me. I changed a setting here in a stream. Here, earlier it was normal latency, but now it is low latency, so you can no lagging. Yep, now latency is like low. At max, it is 15 seconds at max, but normally it is 7 seconds. So that is cool. And we can begin to do the next question. Cool. You are given an array A consisting of n positive integers. Initially, you have an integer x equal to 0. During one move, you can do one of the following 2 operations. Choose one, exactly one, I in the array. Increase I by adding x, then increase x by adding 1 to x, okay, or just increase x by 1. The first operation can be applied no more than once. I can only increase one number one time by x. Okay, your last task is to find the first operation can only be done once. Your task is to find the minimum number of moves required to obtain such an array that its element is divisible by k. The value k is given. K. I have n, I have k, I have the numbers, and x is initially 0. And I can perform this to each. Okay, that is cool. That is cool. This x will be increased. K. Modular arithmetics. Find the remainder with k. Okay, shit. The only thing that matters is their remainder with k. And yeah, n and k. Only thing that matters is their remainder with k, n, k, I than n. For int I equals 0, I less than n, I plus plus, cn, ai, and ai remainder equals k. And then start a dot begin a dot end, and now what? 1, 2, 3, remainder or remainder k minus 1. Take the remainder and ai remainder with k, remainder with k, take remainder with k, and then ai minus equals ai equals a minus ai, and then ai remainder with k. Yes, that is correct. Now ai is the number that I need, is the value of x that I need. Then I will sort it. Int or int would suffice. Int would suffice. What are the values? AI is pretty big. Yeah, cool, cool, cool. That is not that bad. Cool. And now for int I equals 0, I less than n, I plus plus. If not ai, continue, and int x equals 0, and all I need from x is the remainder. All I need from x is the remainder. No. Yes, x is always increasing by 1. So that this is correct. This is correct. This feels correct. Right. If x, if adding the current x to AI is not enough, then I first need to do that operation. Then I first need to bring x up to that value that is required, which is yes, which is x will be equal to a I, and response would be increased. First it is response plus equals a I minus x. That is how much I increased x. So it is done for this particular thing. Yep, yep. Or I don't even need this. I don't even need this. I don't even need this. X is always increasing by 1. Right. Yes, 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 yes. When some values of AI are same, that is a real problem we have to look into. So a better thing here would be a set instead of a vector, a set of a multi set. Is it important? Yes, it is important because I need upper bound and lower bound things. So yeah, and in this whole thing, wherever you see substitute a AI with AI with C. Okay, it is wrong. Replace with C. Okay, that is bad. Replace with C, and now if C, then A dot insert C. No need for something like this, and no need for while all the things are not done. So while not A dot empty, what I will do auto iterator equals A dot lower bound for the current x. Lower bound. And I am making sure that whenever I leave this, x is never greater than k. X is never greater than k, and when I am inside, then I always have this, right? Go to IT equals x. If perfect, either there is a perfect match, or I need to go up, or I am pointing to the end. if I am pointing to the end, then there is one thing. If it equals a dot end, if I am at the end, then x, then res plus equals k minus x plus the smallest element in A. How do I get the first element in A? Uh, Go to A dot begin. That is the smallest element. And yep, when I have done this, x would be equal to this smallest element plus 1. Go to A dot begin plus 1. And I will remove this element from the set, from this thing set. So A dot erase A dot begin when it is equal to the n. Else if that value exactly matches x, then x plus plus and let's plus plus because I did one thing, and E dot erase this element, and then else if the value is higher, then there will be, the value will never be lower, it will be either equal or that. Rest plus equals, and go to it minus x, that is how much I need x to be, and after I do this, x will be equal to, go to iterator, whatever the value is at this iterator, plus 1, and a dot erase this iterator. I think we are cool. See out. Let's hmm, hmm. Seems like we are not cool. Okay, it says 7 here and 10 below 4. Okay, what even was the question? Make everything divisible by k. Okay, find the max. So I guess we can do this in this way. Ad hocish question. Find the max frequency of remainders that many cycles we have to repeat. Okay. Map where the key would be the remainder and the value would be how many times we have seen that remainder. If we do that, then yes, we would need that many cycles. Yes, shit, we would need that many cycles to make everything equal to that thing, equal to, yeah, okay. And then max frequency equals number of cycles. Shit, and since it is max frequency, every other number would be covered. Shit, every other number would be covered because all of their frequency is lower. That is actually genius. That is actually genius. Shit, every other number would be covered because just because shit, because I will have that value of x which is required to make them divisible by k. Shit, that is genius. That is genius. That is genius. Okay, shit. That is cool. The maximum frequency. A map would do the remainder that is appearing the maximum number of times. Yep, okay. But that is actually cool. Shit, that is actually cool. This equals 0. Hmm. K's value can be as big as 10 power 9. So map, when I create a map, I will store stuff in the map for the remainders, and then I can iterate through the whole map and find the biggest number. But after I implement your solution, I will implement the thing that I was trying to implement because I want to get it right in that manner also. Remainders is not a right good word to describe this. Required for int I equals 0, I less than n, I plus plus, and cn, c, taking c, and yep, rec c plus plus. After this, max is 0 for int I equals for auto x, y in rec. Max equals maximum of mx or y. I now have the maximum frequency that I would have to do, and I would also have to get up to this thing. So and this feels like cheating. This is actually cool. This feels like cheating. Uh, yep, I would also need the x value for this thing. So int mx rec does not matter. Now if y greater than mx, if y greater than mx, then mx equals y and mx rec equals x. And here what we would have, okay, here what we would have is first, wait a minute, wait, shit, that is shit, yes, I have to do the other way around, and wait a minute, I'll be right back in a minute. Just wait a minute, I'll be right back. Yep. And yep, I'm back. That is cool. And Aski, any books other than CS stuff like our English and general knowledge is good. Okay, let me. Yeah. Currently, I'm reading this. I will start reading this today. That is cool. Dune, God Emperor Dune, the fourth book in the volume in the series. Dune is cool. Dune is actually pretty cool. One of the best. Yeah, I would say one of the best things. One of the best books that I have read. Dune is cool. And I just completed reading The Stranger by Albert Camus, and that was absurd if you get the pun. And time is ticking. So let's get back to the question. We need to convert this thing into a better thing. Take the remainder with k and c minus c equals k minus c, and then yep, c minus equals k minus c, and c remainder equals with k. And now that is going to be our key. And this thing would be a mixed rec, because first I would have to go up to that point and then plus k into y minus 1. What is y? Y is nothing. It is mx. Fiction and non-fiction. Yep, both. Currently, I'm just reading fiction, but I also have non-fiction. I've read Dostoevsky, and he is pretty amazing. I have The Idiot by Dostoevsky and Brothers Karamazov, Crime and Punishment. Idiot is one of Idiot is also pretty cool. Very good book. Max Rick. That is how much I require. Okay, only add this if C. Only then add this. If it is 0, then don't. Makes sense. Because it is already there. Why negative? Negative does not make any sense. Mx equals y, mx rec. Is it because I do this? Okay. Rec C is the number of numbers that require C to be added to them. Yes, which require C to be added to them. And then I am finding the number which requires the most, the remainder that appears the most number of time, the maximum number of time. If I skip this part, I can do a little translation here. Mx rec would be equal to mx rec x is the remainder with k, so k minus x, and take its remainder with k. What is x? Good question. But yeah, I don't have to take remainder again because max rec is not equal to 0. That is cool. max rec, go up to max rec, what is required, and then k. Shit, no, k is wrong. I do not have to multiply by k. I have to map only if remainder is not k. I mean, rec is not k. C will. Here, c could be 0 when the current number that I got is divisible by k, exactly divisible by k. And when that is, we do not add it to our remainder. We do not need anything. But the thing is, shit, this should work. This should work. This should actually work. This should actually work. Always one less. Go up to max rec, right. And then I have m minus 1. When I add k, I'm right back there. When I add k, I'm right back there. K into max I minus 1. Something seems to be very, very wrong. Zero to max rec is max rec plus 1. Uh, if I- uh, if max rec is 1, then I just need to add it once to get up to max rec because I already am at 0. Right? If max rec is 1, then I need to perform the operation once to get to 1. And if it is 2, then perform the operation twice. I will be at 2. That is cool. Alright, that is cool. Because if max rec is 0, if everything is divisible, then this should be 0, right? And yes, do this operation x, yes, x starts at 1 to get x equal to 1. I have to perform the operation once. I from 1 to n. There's something wrong with the way that we are doing the interval part. 3, 4, 5. If I'm here, laptop is running out of battery. Now it is cool. If I'm here, then add 1, 2, and if it is 6, 2, 3, 4, 5, 6, it did require 6 things. But when I was here and I performed the operation once, then I started from this point. I started from this point. Let's say k equals 3 and max rec is 1. So initially I got here using one operation, and then 1, 2, 3 to get back here again. 2 minus 1 into 3, that is 3 plus 3 equals 4. And is 4 correct? When I came here once, so 1, and then I performed the operation on one of the numbers. Then I came here, right? So plus 1. Then I went here and plus 1, and then I went here plus 1, and when I'm here for the last time I have to perform the operation one more time. Yeah, so answer would be 5. Okay. And yeah, and plus 1 only if max minus 1 is 1. So plus max minus 1 greater than 0. If it is, then 1, otherwise 0. Oh, almost, almost there. Regarding CPU, like consider 30 days, a month, and solve 4 problems in rating range where we struggle a bit, not more like x plus 100 where x is our current rating. Then in a month we have done 100 plus questions of particular rating. Most of the top competitive programmers who are yellow and red GM have solved 100 plus questions per rating change. Yeah, we just have to be consistent. Solving 5 questions, 4 problems every day. Yeah, 120. Yeah, it is cool. That is what I'm trying to do, right? And in every rating I'm solving 30 questions. I guess that is not cool. 30 is not enough. I would have to do more, but whenever I see a topic which is new, I go and read about it. So that is also cool. And my timer is running. Yeah, this is a nice thing. We just have to be consistent, and let's say your base rating was 800, right? Which is very basic, which is very normal. And if you do this, let's say in 1 month you would be jumping a rating of 100. In 2 months you would be 1000. In 7 months you would be 1500, and in a year you would be 2000. So that is cool. That is actually pretty cool if you do that. Consistency. In the last one we are getting the wrong answer. Make them divisible by 8. Max is 1. That makes sense. Okay. I went up to 7. If it is equal, no, they are already sorted. So yeah, I don't need this. I don't need this. They are already sorted. Why does it say so? Now I get your point. Now I get your point. Shit, shit, shit. Now I get your point. It was for this thing. Shit, shit. Because we consider a number done. Let's say I need a remainder of 1. We consider a number done when x becomes this required number plus 1, which means we performed the operation when x was equal to this number. Shit, okay. Mhm. Except in this case, when max required is 0, mx rec. If max required is something, then do this whole thing except 0. Ah, it is 0 in the third case. Why? 1, 2, 3. Here, 10, everything is already divisible. So max rec should have been 0. If rec dot empty, then see out 0 with a new line and return. I don't check for this. Okay, finally, even though the idea was pretty amazing. Discord link is expired. Discord link is expired. Okay, I will fix that. I will put the latest one in the channel's description. That would be cool. Yep, and we are not adding to map the 0 valued remainder. I mean, we don't have to, because when the remainder is 0, then we do not need, yeah, then we do not need to add any value, anything, right? When remainder is 0. Yep, I think that is the logic I am thinking of. Copy this thing, and this would be what? The third question for the day. If we get this correct, I think it is 40 minutes. Shit. Uh, I mean, if I also add 0 as one of the things here, if I also add 0 as one of the things here, then it would not work. If the remainder is 0, then I do not need the thing, right? Okay, let's write this from scratch. Int n cn n and also k. Shit. Now I am struggling. And then a map of integers, let's call it rect what is required for int I equals 0, I less than n, small n, I plus plus, and in C, C into C, and whatever the remainder is, C remainder equals K, and if C, only then add C to the map, because if the remainder is 0, then I do not need to do anything with that number. If the remainder is 0, that number is already divisible, right? I do not need any cycles or anything. Then rec C plus plus, and then int mx equals 0, or before this, if rec dot empty, then cout, everything is divisible, cout is 0, and return, and if not empty, then there are some values which need something. Yep. And okay, auto for auto x comma I y going through rec and int mx initially 0, mx count is 0, and int tx as in like target x is something, does not matter. And now cnt equals maximum of cnt or the current y, or not even that. If current count is greater than cnt, then cnt equals y and target x equals this x, and then int response will be equal to target x plus 1 plus k into cnt minus 1, and then see out the result. Mhm. That does not make sense. If y is greater than, of course it does not make sense. Okay. This has to be reversed. C minus C equals k minus c, k minus c, if c lower than k. It is becoming cumbersome. That's why you are getting in third case. Bigger pain than heartbreak. This is painful. But we can have condition that if max equal, then find the second maximum frequency, or else we do as previously. Yes, we can do that. We can do that. I just want to now get this thing done, and 2 is not even close to the correct answer. Is it taking 1? It is taking 1. Okay. Hopefully. Ah, shit, it was integer overflow, not any logical error. Shit. Okay, now we cool. Now we cool. Is it again integer overflow? I think it should, yeah, it is not integer overflow. It is not integer overflow. It is just pure wrong answer on test 5. Okay, let's go through this again. C plus plus, yes, rec C plus. That is what I need. Yes, and if rec is empty, C out 0. I do not need any. I do not need anything in that case. Yes. I don't know why I feel really, really bad. Count is 0. Max count if the current count is greater than or equal to this thing, then update tx, target x and cnt both, and then result is going to be tx plus 1. Tx is never equal to 0. Tx is never equal to 0. Yes, that is correct. Plus k into cnt minus 1. That is how much is remaining. Okay, I will look at the thing that signed integer overflow. Wait, are they asking for the modulus? Makes so much sense. Makes so much sense. Ah, shit, shit. 15 minutes, 15 minutes, 15 minutes, 50 minutes, 50 minutes. Anyways, let's go. Yo, let's go. Your idea was pretty amazing. Your idea was pretty amazing. Your idea was pretty cool. Just find the one with the maximum, and when I'm trying to cover that, everything would be covered. That is actually pretty cool. Yes. Shit. Yes, that is. I would not have been able to do that. I was trying to simulate the whole thing, which is not good. Like, obviously, which is not good. Hello, all India tour. Shit. Hello. And the tags. I think the tags are going to be modular arithmetics or mathematics. And yeah, what else? What else? Data structure for map, but modular arithmetics would be there, or mathematics. Sorting, yes, we used map for sorting, so that is fine. And 2 pointers, you could say, if you are using the other method which I was trying to use, the bad one. And now D. Done by Mr. Mike. Zero remainder array. Okay. First, we can understand that during each full cycle of x from 0 to k minus 1, we can fix each remainder only once. That is the insight. Notice that when we add some x, then we fix the remainder this, and we don't need to fix elements which are already divisible by k. So let CNTI be the number of such elements for which the condition equals I holds. That is, they need I to be divisible by k holds. And that is the number of such elements that we can fix. If we add the value I mod k to them, we can count this using some logarithmic data structure using map, or we can just while we were taking the input. So what is the number of full cycles? It equals to the amount of most frequent element in CNT minus 1. So the answer is at least k into maximum count minus 1, and there can be one last cycle which will be incomplete. Count minus 1 into k, count minus 1 into k, count minus 1 into k, but this also to get up to that thing, and there can be one last cycle which will be incomplete. So what is the remaining number of moves? It equals the maximum possible I among all this makes shit. Yes, to get up to that thing. So if key is the maximum such that I is the okay, key is the maximum where, right, key represents the remainder that appears the maximum number of times, or key represents the number that is required maximum number of times to get up to k, to be divisible by k, then the answer is this thing plus key plus 1. That is what we do. Tx plus 1 into k into CNT minus 1. That is cool. That is exactly what you said. That's cool. It is the same idea that we have done. Yes. What is your favorite competitive programmer? Who favorite at coders? Right now, I'm just learning things, and I think if I am good at one platform, I will be good at all the platforms. And favorite is a tricky word. I watch Eric To's videos, and I have watched a few tourist streams, and they both teach me different things. I like them both, and they are the only people whose videos I have watched. I have also watched video. I was watching an interview of Radevush, Radevush, who is, I guess, right here, Radevush interview. Yeah, no one in particular. Favorite is a very tricky word. No one in particular. So we have done 3 questions at least, and let's do one more. At least four, like just like you said, at least 4 questions. Johnny and the another rating drop. Okay, and before I begin, I'll just get back from the washroom. I'll be right back because I want to get this one correct in time. That would be cool. I would try to do this on my own. In the last one, I took your help, and okay, in this one, I will try to do this on my own. Not that I will try to. I will do this on my own. That is cool. And yes, I'll be right back. Let me pee. I am back. And the latency now is much lower, which feels really cool. This is like actually cool. This almost feels like a real-time interaction. And now beginning the next question. Cool. The latest contest held on Johnny's favorite competitive program platform has been received rather positively. However, Johnny's rating has dropped again. He thinks that the presented tasks are lovely but don't show the truth about competitive programming skills. The boy is now looking at the ratings of consecutive participants written in a binary system. He thinks that the more such ratings differ, the more unfair is that such people are next to each other. He defines the difference between two numbers as the number of bit positions where one number has 0 and the other has 1. We suppose the numbers are padded with leading zeros to the same length. So that is XOR of the two numbers. He defines the difference between two numbers as the number of bit positions where one number is 0 and the other is that is OR. For example, for these two, the XOR would be at this place and this place equals 3. Different 3 positions. Okay, shit. Yes, in the first, in the second. Okay, take the XOR and then the number of bits that are 1 in XOR. Okay, pop count. Johnny defines the unfairness of the contest as the sum of such differences counted for neighboring participants. Johnny has just sent you the rating sequence. Johnny has just sent you the rating sequence and wants you to find the unfairness of the competition. You have noticed that you have got a sequence of consecutive integers from 0 to n. Okay, from 0 to n. That's strange. But the boy stubbornly says that everything is right, so help him and find the desired unfairness for received numbers. Ah, the input lines consist of t test cases, the number of test cases t, and the first and only line in each test case is a single integer. Okay, do not tell me. Now for n equals to 5, we calculate unfairness of the following sequence numbers from 0 to 5 written in binary with extra leading zeros. So we cannot run our loop n times because n is very big. N can be very big. We cannot run it that like that. The unfairness between this and this is 1, between this and this is 2, between this and this is 1, between this and this is 3, yes, and then between this and this is 1 for this, and the sum is 8 and 8 is the answer. So I need to figure out some formula which I could use. Okay, first of all, let's take this all in. Boilerplate, blade, then long n, seeing n. And now that we have n consecutive, I need to find a formula. Yep. Zero, 2, 4, 8, and answer if n is not 0. So n, let's say n is 2, I would have 0, 0. 1. Okay, we can say 1, 1. When n is 1, so 0, 0 and 0, 1, 1 bit differs, answer is 1. When n is 2, wait, this is dynamic programming? I can pre-calculate the whole thing for n, right? Then just output this thing. Yep, it only depends on that. But no, I cannot go through all the n's because n is very big. No, 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 no. A loop, a loop is bad. I do not want any kind of loop. When n is 4 at max, I would have this. And just before this, I would have definitely have this. In which case, answer is 3 in this much. And then just before that, I would have 0, 1, 0, 1 bit would differ. So 1, and now we are again to square 1. I think whatever number I get, I can divide it into powers of 2. Let's say I get 20. So powers of 2 would be 1, 1, 0. This is in binary. And 1, 0, 0 for 4. Then 1, 0, 0, 0 for 8. And then 1, 0, 0, 0, 0 for 16. And I think I can calculate the answer for each interval efficiently. Let's see. For interval 1, 2, 1, 3, and 1, 2, 3, 4. For this thing, I have 4 zeros, and here I have 3 zeros. Power is also 4 here. Power 2's power is also 3 here. And in this interval, if we go like this, then before this, I must have had this number. So add 4 to this, and I'm trying to look for a pattern in this. And before that, I subtracted 1. So 0, 1, 1, 0. 1 and 0, 1, 1, 1, 1, because only this bit differs. And don't we know the answer to this thing? Answer to this thing would be 1, 1. If I subtract 1 more, then I would have 0, 1. Answer to this thing, that is 2. When n equals 2 is 0, 0, 0, 1, and 1, 0. Answer is 1 for this, 2 for this, 3. Wait, whatever are the up bits in that, do I have to just calculate the answer for them and do my work? For 11, let's see. For 11, I can pre-calculate for n equals 1, for 2, for 3, for 4, for 5, for 6, for 7. Okay. And when n equals 11, no, don't look at it, don't look at it. 11 in binary would be 1, 8 plus 3, 2, 4, 8, this thing. So answer would be answer for this bit, answer for this bit, for this bit. When n equals 1, that is for this bit, answer is 1. For n equals 2, we saw before, answer is 3. This is wrong, this is wrong. Right, because I double counted. Yep. Take the answer for this bit, subtract the answer for this bit, which are 0. Yes, take the answer for the highest bit, subtract the answer for all the 0 bits in the number. So, okay, for n equals 4, that is this bit, what would be the answer for this? The answer for this would be this. Answer for 2, which is 3 plus 2, I think 5. Answer for 3 plus 2, 5. Let's check this. Answer should be 5 for 4. Subtract 1, 1, 1. And now answer for 2 plus 1. Let's see. I would have 1, 0, and 0, 1, and then 0, 0. For this, the difference is 3. Then for this, the difference is 1. And for this, difference is 2. And for this, difference is 1. That is greater than 5. That is actually 7. That is 7. And it is because when I added 3, I have to add the answer for 2, which is 3, and the answer for 1. No, 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 no. Okay, there is a pattern here. There is a pattern here. And yep, we can find the binary string and count for each bit. Count for each bit, and that is what I'm trying to do. If I get your suggestion correctly, we have a number. We convert the string into binary bit set. If I have 11, 1, 0, 1, 1, that is 11. I think adding the answer for all of them is correct. Yes. Adding the answer for this is 1. Answer for second bit is 3. For this, I don't know. When n equals 8, what is the answer when n equals 8? 8 is 1, 0, 0, 0, then 1, 1, 1. That is 4. But there is something that I'm missing. There is something that I'm missing. When I have this, and I already have calculated the value for this, and this, can I not just add them, which would be equal to the prefix plus the current value? Okay, which would be equal to the prefix plus the current value. This represents power of 2, n. When power of 2 is 0, we will start with that as a base case. And then the last one, plus 1. Yes, this thing minus 1 plus 1. Okay, 1. And then the last thing, that is 1 plus this thing minus 1 plus 1. This should be 2. But this is not actually 2, is it? 2 power 2 is 2 power 0 is 1 and 0, 1 answer is 1. And what is the answer for 1, 0? It is power plus 1, 3, last thing, 3 plus power plus 1, 2 plus 3, 4. This turns out to be 6, but we calculated that it is not 6. 2 power 3 is 8. 2 power 2 is 4, which is 1, 0, 0, then 0, 1, 1. That would mean add this, add this, add. Okay, there is something wrong with my representation. Let's start with 0. 2 power 0 is 1. Okay, and answer for that is 1, which is correct. And 2 power 1 is 1, 0, 0, 1. Here we have this same thing again, whose answer was 1. So I can add 1 for this thing and then 2 for this thing, which is correct. Answer is 3. And then for 2 power 2, we have 4. Makes sense. Makes sense. Just adding the last bit is not cool enough. We have to add every last bit. So we would have this thing, and yep, we would have this thing, and we would have a prefix where this is 1, this is 4, and then 4 plus 2 plus 1, 7, and then 7 is the answer here. 7 is the answer here, and here we would have 4 plus 7, which is 11. And then the answer for this thing would be 11 plus 4, which is 15. And we can check. We can check. 3, when 2 power 3, it is 8. We would have 1, 0, 0, 0, 1, 1, 1, and then 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1 for this thing, 2, 3 in total, then 1 again, 4 in total. Then in this we have 3, so 7 in total, and here we have 2, so 9 in total, and here we have 2, which is 11 in total, and here we have 1, so 12 in total, and here we have 4, 16. Okay, I messed up. I maybe messed up because above the answer was 15. Maybe I messed up. Let's go from here. Here I have 4, and then we have one difference, 1. So we add 1, and then we have 1, 2 things different, so 2, and then we have one thing again different, so one, and then we have three things different, so three, and then we have one thing different, so one, and here two things different, and here one thing, so 1 plus 2 3, 3 plus 1 4 5 8 10 15 15. Yes, cool, 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 cool. Cool, this is doable with some pre-processing. This is doable with some pre-processing. This is, we would need a bit set. No, no, no. And modulus, do I have to take? Nope, doesn't seem like it. Good morning. Yo, good morning. How are you? Let's be safe. Pref. Okay, how many bits? Const int range equals 64. And let's go with range here and vector ll res for void fill res with nothing, and in this pref 1 pref 0 would be 1, and res 0 would also be 1, and now we can start iterating for int I equals 1, I less than range I plus plus. What we do is, for the benefit of the all, okay, what we do is this I equals pref I minus 1 plus I plus 1. I think that is correct, and then pref I equals prefix I plus 1 plus res I plus res I. Hmm. Prefix of I plus 1, and for cool, cool, cool. That is correct. That is absolutely correct. Cannot be any more correct. And here, fill res to fill everything. And yep, we would have a bit set of size range, let's say, and call it B and initialize with N. Unsigned long, what is the problem? Unsigned long. Now I have the bit set. Now for int I equals 0, I less than range I plus plus, and int or long response equals 0, or response is not a right word for this. Let's call it answer equals 0. That is where we begin with. And if bi, if current bit is on, then answer plus equals response for that current bit, and cout res I. What is res I? What the heck is this? Cout answer. Okay. Shit. It has only been 24 minutes. It feels like a very long time. Shit. This one was cool. If I get this correct, it would be cool. It would be cool. Wait, did I mess up? I might have messed up. Okay, I didn't. That is cool. Okay, I can. I feel like I can be actually happy for getting this one right in first try. This one was cool. This one was actually cool. This one was actually cool. Yeah, recursion. And in the tags, I would see a recursion DP, recursion constructive algorithm, or none of those things. This was actually cool. This was actually cool. 25. Oh, shit. I feel hot. Hmm, cool. Cn return 0. Yo, can you explain it? Yep. Use 0. Use return 0. That too in less than 30 minutes. Yep. Yep. This was cool. This was cool. Okay, so what are we doing? Even I don't know. I would have to review this. Review. Okay. Let me try to explain. Okay. When I have n, what I need to return is, let's say n is equal to 7. If I represent 7 in binary, what I need to return is this. Go from n to 0 like this. If n is 7, then go from 7 to 0, which in binary would go like this: 1 0 1 and 1 0 0 and 0 1 1 and 0 1 0 and 0 0 1 and 0 0 0. And what I need to return is, look at all the adjacent pairs like this. This is also adjacent. This is adjacent and that is adjacent, and see how many of these bits differ. In this one, only this bit differs. So for this pair, the unfairness index, or remove that, the response for this pair is 1, and then for the next pair, here 2 bits are different, this one and this one. So 2 for this, and then for this next pair, 1 bit is different, so 1. For now this next pair, 3 bits are different, all 3 are different. Then for this pair, only this one is different. Then for this pair, 2 bits are different. Then for this pair, only 1 bit is different. So the answer would be 1 plus 2 plus 1, 4 plus 3, 7 plus 1 plus 1, 10 plus 1, 11. Answer for n equals to 7 would be 11, which we can check, Let's see, Johnny case, and that is 7. 11 is the correct answer for n equals to 7. Now, what is the insight in this thing? The insight, first I was trying to see maybe n is somewhat, since we are doing binary things, then n might be close to some exact power of 2, and that might help me in some way. But then, let's say, when I am trying to find answer for, let's say, n equals to 4, which is a perfect power of 4, which is a perfect power of 2. And in binary, it is represented like this. And if I just go 1 below this number, it is going to be this. 4 minus 1 is 3, which is this in binary. And for this pair, the difference is 3, right? For this pair, the difference is 3. But then now when I move down, what I do is 0, 1, 0. And isn't this thing same as finding the answer for n equals to 1? When n equals to 1, the answer is 1 first number is 0 1, the next number is 0 0, and the answer would be 1 here. And isn't this the same? And when I have done this step, after this step, what I am left with is 1 0. And isn't this the same as calculating the answer for n equals to 2, right? And if we were to iterate for n, and by n, I mean n is the power of 2. So if we were to take some big value of n, let's say 5, then we want answer to something like this. And after the first step, the whole thing becomes like this. And this step, the answer for these two pairs is 5, which is the power of n that we chose. And now what I have to do is, to this answer I have to add the answer for this thing, because when I am done with this thing, the number that I would have is 1 1 1 0. And when I am here, I need to add the answer for this thing. When I'm done with that, I would have a number like this. And when I'm here, I would have to add the answer for this bit, and I would have a number like this. And at last, I can add the answer of this thing. So if I iterate through n equals 0 to power 0, which is going to be 1. And for that, answer is going to be 1, which I do initialize at the start here. And there is some clarity, some details that we have to keep in mind. That is why I'm using a prefix. And yes, I can just iterate through n equals to 1 till the largest value of n that I can choose. And n is, again, to say it again, to repeat, 2 power n. And the largest value for n that I could have is 63, because I am using a 64-bit number. It uses 64 bits. That is the insight. Use return 0. What do you mean by use it? Or in the main function? And that in, yes, it is. If there is a pattern like that, what is this pattern? Well, that is Pascal triangle. 1 1 1 1 and 2 2. Here is also 1 3 4, and here is 1 3 7 7 1 4 1 4. Yep. Okay, I don't get the pattern part, because the if I start adding if I consider this pair as the first pair, then the value for this pair is 5, and then the value for the next pair is 1. Okay, shit, there might be a pattern after that. 0 0 0 0, right? And 1 0 0 1 1 1 1. Answer for this is 5, and we go 1 1 1 0. It is 1, then 1 1 0. Yes, 0 1 2 1 1 0 0. 1, right? And then 1 0 1 1 3. Yes, shit, there is a pattern. And when I reduce again, it would be 1, then it would be 2, and I suppose it would be 1 again, and then 1. Shit, okay, there is a pattern, there is a pattern, there is a pattern, there is a pattern, there is a pattern. And what is this thing called? This is very similar. This is not very similar. This might be similar to this thing. No, 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 it is not. It is not because the largest number is in the middle. Shit. I think this might be a pattern, and I would like to know the name of this pattern because if I see this pattern again and I need to find the summation of this pattern, I can use the same code in that question also. Uh, let's go to ChatGPT, of course. ChatGPT is much smarter than us. Okay. What do we ask? I have, or we have stumbled upon a pattern, and can you tell us its name? It is 1, 2, 1, 3, 1, 2, 1. Or maybe we should have added till 4. Gemini Pro. I just go to ChatGPT. I mean, for 1 year. Shit, that is cool. That is cool. Okay, I will get a free thing in Gemini Pro. A palindrome. That is the start of the ruler sequence, also called two-adic values, p-adic numbers, valuation sequence. Definition: nth number will be equal to when v2 is a function where v2 is the exponent of 2 plus 1. Okay, yes, this is somewhat the pattern. Wait, no, this is different. Okay, I will look into it. I will look into it. Rulers sequence. It is called rulers sequence. Okay, we can add that into our notes. And it has been a long stream, 3 hours and 24 minutes. We have done quite a few questions. We did 4 questions today, actually. That is cool. That is cool. And in today's stream, the latency was also really low. And we have this cool thing with the camera. If I move around, my camera follows me, which is cool. And this would be the end of today's stream. And thank you for being here. Bye.